Let's tackle number 10 on the 12B. In the xy plane, a circle of radius 4 and center on the positive x-axis is tangent to the y-axis of the... Okay, let's just draw what's going on here before we get lost. XY plane, circle of radius 4 with center on the positive x-axis, tangent to y-axis at the origin. Something like... You know what, let's draw a better circle maybe. A circle of tangent to the y-axis of the origin. Circle of radius 10 with center on the positive y-axis is tangent to the x-axis of the origin. So center on the positive y-axis, we got something like this, right? And we're asked to find the slope of the line passing through the 2 points where they intersect. This is an interesting problem. So tangent to the y-axis. So this circle. So as I mentioned in all geometry problems, draw all important radii. Always. You know that by now if you've been watching this channel for some time. So we have here, draw all important radii. So we have 10 here, and then 10 here. And we're trying to find the slope of the line. So there's something really cool. It's like a advanced concept, kind of. But if we have two circles, it's well known that if you connect the centers and you draw what this is called the radical axis, they're going to be perpendicular. This is a well-known property. So in this case, and even if you didn't know this property, you could probably guess from this diagram. Like sometimes you just have to take a leap of faith, right? Like this looks pretty close to 90 degrees. You know, it probably is. It's just a really cool property. And intuitively it should make sense, right? We have circles here, and then we have this line here, right? This is the horizontal line, and this will always be like the vertical line in respect to the centers. Because, you know, the top point will be symmetric. It's not compared to the bottom point. Like the bottom point's not going to lie over here. It's going to lie right below the top point. That's why it's going to be perpendicular. It's going to be a vertical line. So that's why this property is true. And then, so if we're trying to find the slope of this line, all we have to do is find the slope of this line. And then we can use our inverse, reciprocal formula. The slope of this line will rise over run, or we can just see, okay, negative 10/4, so negative 5/2. And then by our inverse reciprocal property, this thingy is just going to be 2/5. So a pretty nice problem. The key property was just realizing that these two lines are perpendicular. And that's a really common property in geometry. I hope you enjoyed this video.